Welcome to Spring LIB.
In this problem, we're going to be talking about force and acceleration. And the concepts we need in order to solve it are, first, Newton's second law, which tells us that the sum of all the forces that act on a body, which we call the net force, is equal to the mass of the body times the acceleration. Okay, we also need to know that the friction force is equal to the coefficient of friction. In our case, we're going to need the coefficient of static friction times the normal force. Okay, so we are ready to dive into the exercise. We have the system that's shown here in the figure. We have two blocks, A and B. Both of them have mass m. And block B, both block B and block A are shaped in the form of a right triangle. And block B makes an angle of theta. The triangle makes an angle of theta, as shown in the picture. And a force P is exerted on the right side of block B, such that block B and block A, they travel together. They have the same acceleration. We have the information that the coefficient of static friction between the two blocks is mu s. And our goal is to find what is the maximum value of P such that the blocks will still stick together. In order to solve the exercise, we need to draw the free body diagram for both blocks. So we have first the A block, and the forces that act on this block are the gravitational force, mg. We also have the normal, n prime, that is the force that block B exerts on block A. Okay. And we also have the friction force. Notice that block A would tend to slide in this direction. So this means that the frictional force will be pointing in the opposite direction. Okay. And now we can draw the force diagram on block B. So this is block B. mg points downwards. The normal force that block A exerts on block B and prime has the same magnitude as the force that block B exerts on block A according to Newton's second law. And the opposite direction, we have the normal force that the ground exerts on block B, and we have P. Okay? So now we can write the equations of motion for both blocks. First, for block A, in the y direction, we have, remember that this angle here is theta, which means that this angle here, let me just draw it a little better. This angle here is also theta. Okay, which means that n prime, I'm going to choose a coordinate system such that the y-axis points upwards and the x-axis points to the left. We have n times the sine of theta. I'm sorry, actually we should start with the y direction. So we have n times the cosine of theta minus mg minus the frictional force times the sine of theta is equal to 0 since the blocks are not moving in the y direction. Then in the x direction, we have n prime times sine of theta plus the frictional force times cosine of theta, and this is the mass times the acceleration. Okay. Then for block B, we have, again, this here is theta. Let me write it here, actually. It will be a little cleaner. So for the y coordinate, we have minus n prime times the cosine of theta minus mg plus n, and actually there's also the frictional force, of course, that points in this direction. I'd forgotten to write, plus the frictional force times the sine of theta, and this is equal to 0. In the x coordinate, we have minus n prime times sine of theta plus p minus the frictional force times cosine of theta is equal to mg. Okay. So what I'm going to do is try to calculate what is the maximum value of p. In order to do that, first, I'm going to need to calculate n prime and the acceleration a. Okay. And first, notice that the maximum value of the frictional force is mu s times mg. Okay, mu s is the coefficient of static friction. Mg is this shouldn't be mg because in general this is not a normal force. This is just the frictional force must be smaller or equal to mu s times the normal force. In this case, n prime, this is the normal force that B exerts on A or A exerts on B. Okay, so this is the maximum value of F. And I'm going to insert this into the equation in order to find the maximum value of n prime. So I'm going to take the equation for block A in the y direction, this one here, and I'm going to insert this formula for the frictional force. So we have n prime cosine of theta minus mg times minus mu s times n prime times sine of theta. And this is equal to 0. Okay, and notice that this is the maximum value of the frictional force. So the value of n prime is also maximum here. So we have that n prime times the cosine of theta minus mu s times the sine of theta is equal to mg, meaning that n prime, that is the maximum value of n prime, is mg divided by cosine of theta minus mu s times sine of theta. Okay. Now we can take this and substitute it into the second equation for the x coordinate. So we have n prime, which is mg divided by cosine of theta minus mu s sine of theta times sine of theta plus the frictional force, the maximum frictional force, which is mu s times n prime cosine of theta, and n prime here is mg divided by cosine of theta minus mu s sine of theta times cosine of theta. So this is equal to the mass times the acceleration. Now notice that the mass cancels out, and we are left with g times mu s times cosine of theta plus sine of theta divided by cosine of theta minus mu s sine of theta. And this is the acceleration, a. Now, since we're working with the maximum normal force and prime, we're also working with the maximum acceleration a. Now, let's go back to block B and work with the equation for the x-coordinate. Okay, and actually, there's an error here. This shouldn't be mg, this should be ma. I'm so sorry for that. Mass times the acceleration, because it's the sum of the forces. Now notice that the maximum acceleration corresponds to the maximum value of p. So we can isolate p in this equation with the acceleration we just found and find the maximum value of p. So if we take that equation, we can isolate p. So we have that p is equal to ma plus mu s n prime cosine. Actually, let me isolate n prime as well here. Let me do it as ma plus n prime sine of theta plus mu s n prime cosine of theta. So we can take the equation for the x component of block A and use that n prime sine theta plus mu s and prime cosine of theta is equal to ma. So this is equal to 2 times ma. So the maximum value of p is 2 mg times sine theta plus mu s cosine of theta divided by cosine of theta minus mu s sine of theta. And this concludes our exercise.